Math 2414, other convergence test, video 10, the root test. This is the last video in this series, and I'm sure you're going, thank goodness. But it's going to be a rather short video, especially if you just watched the previous one. Well, it's going to be short regardless, but it's going to be rather easy, especially if you just watched the previous video about the ratio test, because this looks almost like it. The only difference is the limit that you set up. Let the sum from n equals 1 to infinity of an be a series, and L equal the limit as n approaches infinity of the nth root of the absolute value of an. Then the same conclusions as before. If the limit is less than 1, then the series is absolutely convergent. If L is greater than 1, then the series is divergent. And if L equals 1, then the test is inconclusive and you use another test. The only difference between the setup here is you're not taking a ratio of consecutive terms. You're taking the current term, sticking an absolute value in it, and putting the nth root over it. Now, you should not use the root test except under one condition. When you have an exponent, when you have an n and a power. You don't have an n and a power. For example, if you had something like this, don't use, well, it's got an n on the alternator, but forget the alternator, you can stick an absolute value on it anyway. But there is no n on a power in the part that's not the alternator. The purpose of the root test is that you have an nth root canceling an nth power. So, for example, let's say you see something like this. Well, we're only going to do one example. The sum from n equals 1 to infinity of the fraction 2n plus 1 over 3n plus 2, all raised to the 2nth power. And the question is, does this converge? Absolutely. Does it converge? Does it diverge? The presence of this n in the power is a dead giveaway that you should try the root test. So let's do the root test. We're going to let L be the limit as n approaches infinity of the nth root of the absolute value 2n plus 1 over 3n plus 2, 2n power. Technically, the 2n should be inside the absolute value. So give me 1 second here. All right, well, first things first. The fraction is positive because n is 1 and greater. And so raising it to a power keeps it positive. So the absolute value does absolutely nothing to this. If there were an alternator, it would get rid of it. So we can lose the absolute value. Or rather, what we're doing is actually executing the absolute value, doing what it says. But because the expression is already positive, absolute value leaves it alone. But the other thing I want to do is talk about what to do with the nth root. I said before, earlier videos, we don't do calculus to radicals, we do calculus to exponents. That's what we're going to do here. We're going to treat the nth root like a 1 over n power, because it is. And the advantage to that is anytime you raise a power to another power like this, you can multiply them. And when you multiply them, the n's cancel. So we end up with limit as n approaches infinity of 2n plus 1 over 3n plus 2 squared. I'm going to do a technical move. I'm going to slide the limit inside. And you can do that. You can move a limit inside a function. In this case, we're moving it inside the squaring function if that function is continuous. It's the core of being continuous. Doesn't matter if you do the function before, the limit before or after the function. We're doing the limit before squaring instead of after squaring. The squaring is continuous. And notice that we have a ratio of polynomials. And so the limit is the ratio of leading coefficients. The leading coefficients here being 2 and 3. Degrees were different, we couldn't just do that. So that limit is 2/3. It gets squared. 2/3 squared is 4/9. 4/9 is less than 1. And just like with the ratio test, therefore we say that the series converges absolutely. Which means it converges without the absolute value, but again, in this one it was redundant because the terms are all positive anyway. So that's all the root test is. You got a variable in the exponent that you wish weren't there. So you hit it with an nth root, which becomes a 1 over n power and cancels the variable that you wish was included. You take the limit and draw the same conclusions as the ratio test. Thought about making one more video summarizing all the techniques, but I invite you in your note-taking journey to go through and summarize all the techniques. I'll probably type something up and upload it to Canvas for the folks in my class. That is the end of this video series. I do want to remind you though that this series covered 2 sections. So if you're in my class, section 8.3 and 8.4, 8.3 was the beginning through the limit comparison test. 8.4 started with alternating series and absolute convergence and all that stuff, and ended with the ratio test.